Hello everyone. Today we're going to complete the assignment 2 classification from the module machine learning algorithm or the applied machine learning. Okay, so I start with opening my browser. After that, open the portal Azure. This is a step you have done many times, so I will speed up this part. So as usual, we open the portal. After that, we log on with the credential that given by the Learn on Demand. Okay, with the correct username and password, then we now log on to the Azure subscription. Okay, for the lab instructions, you can get it from the LMS, which is here in the this one, yeah, number 7, yeah, assignment 2. Classification. Explore classification with Azure Machine Learning Designer. You can revert the step that I'm going to show you in this lab guide. Okay, so in this lab guide, first we need to do a basic step like creating the Azure Machine Learning workspace, because the previous lab already deleted. So we need to recreate again. After that, create a compute instance and create the dataset. So this time we going to create a dataset and use this source from the external source. Yeah? Okay. The first and second step to create the Azure Machine Learning workspace and to create a compute instance, I'll do it myself and quickly. Yeah. And yep, here you go. So as usual, just click create as a resource. After that, machine learning workspace. Okay, then Azure machine learning, create. Okay, create new resource group. So the MLA Assignment2 Archie. Okay, then the name is MLW machine learning workspace assignment 2. Okay, so the rest populated. I do not change anything. Review create. Wait a while, then the create button will be selectable. Okay, I click create and this will take a while. So yeah, in the meantime, while waiting, then we're going to discuss about creating the dataset. So the dataset is from the GitHub, as mentions in the this is the data source. But you need to make this link valid. You need to put HTTPS in front. Yeah? So just copy link the address. Okay, then later we're going to use this clipboard, yeah, in defining the dataset. Okay, now let's look at what the screenshot that we have to take for completion of this assignment. Okay, so provide screenshot to create machine learning workspace as usual. Then compute. Okay, this one is compute instance. And then provide screenshot of the created tabular dataset, and then classification pipeline in the designer, and successful execution of the pipeline, and result evaluation result, and then comparisons, yeah, different classification. Okay, so in total there are 6 screenshot. Okay, maybe I duplicated this, so make a copy, then after that I will create a new one with the answer. Okay, here you go. We rename. Sample, not answer, sorry. Sample. Okay, we open this one. Yep, so completed the machine learning workspace. The next thing is to create a compute instance. Oh, sorry, open the studio. Or if you want, you can also create a screenshot first. This one. Yep, so this one is the okay. This is the screenshot for the machine learning workspace. Then create compute instance. Okay, launch the studio. Okay, go to the compute instance. Compute. Okay, then create compute instance. Yeah, just give the name for the compute instance. The name is Ryan Compute. Yeah, C Compi. Yeah, Ryan Compute instance. CPU cheapest. Then next. So use the default setting as usual. Nothing, no need to change anything. Then create. Yeah. Okay, this will take a while, and we don't have to wait. Later come back again once this created. So now you go to data. We're going to create the data set. Okay, so in the data set, we're going to click the create a new one. The name is diabetes data, and the description is diabetes data. The type is tabular. Okay, then click next. After that, the source is from the web, and just now we copy the location, copy the link. Next, yeah. So the link here, you use this to copy from the clipboard. Here you go. Yeah, then okay. Okay, so this is the data. If you want to check, you can check the data is like this. This is the CSV. Yeah. Okay. So we click the skip data validation, not selected. Next. Yeah. After that, the format setting, delimited, comma, and then only change this. Only the first file has headers. The rest using the default. Okay. Then click next. Okay, so exclude this path, the rest is included. Next. Okay, after that create. Okay, so the dataset is created. You can explore. Okay, this is a column. Yeah. So yep. So diabetes 0 and 1. So 0 meaning not diabetes. 1 is diabetes. Okay. Yep. So that's the explanation. Okay, so we have already created the dataset. Then we check again the compute instance, whether we already have completed the compute instance. Okay, review, we close this. Still creating, yeah, haven't finished. Okay, just leave it. And how about the refresh? Yeah, still creating. Okay, how about the screenshot? Compute instance, provide screenshot created tabular dataset. Okay, so we need to screenshot the tabular dataset. Go to the data. Yep, here again. You go, diabetes data created already. Okay, diabetes data. Okay, we go back to the here again. We close this. Then okay, just leave it there. Go to the designer. Now we're going to click to create a new one, new pipeline. Okay, and then after that we're going to rename to the diabetes training. Okay. Yeah, then for the data, then we drag the diabetes data. Okay, after that, as usual, we're going to populate. You can right click to view the data. This is exactly the same as just now. We already have a preview in Explorer. After that, we're going to complete the pipeline with a few select column. Go to the component. Yeah, select column in the dataset. Okay, so we're going to select most of the column. Okay, wait, yeah, select column. Then after that, choose the choose by name, yeah, by name. After that add all the column, remove the patient ID. Okay, so add of the column, then remove the patient ID, so except for the patient ID. Yeah, so patient ID is just identification, doesn't mean anything. Yeah, so we don't need that for the training the model later. Click save. Okay, after that we're going to normalize some numeric value. Okay, so in normalized data we going to configure using the min max. Okay, after that in the edit column we're going to include the yeah, few column like pregnancy, plasma, glucose. Yeah. This column I already have prepared in the this yeah, here you go. So there is a diabetes column. Yeah, here you go. So you don't need to type, just copy paste. You can copy. After that in the edit column name we use the clipboard. Yes, then press enter. Okay, so this is make sure that no typo mistake. Yeah, okay, then save and close. Okay, after that we're going to run the pipeline. Yeah, run the pipeline. So we check first the compute instance. This should be created already. Yeah, so close. Okay, yeah, so already created. Then we can create a screenshot for the compute instance. The name is Ryan ComI. Okay, so we can put in the screenshot. Okay, after that we're going to run the pipeline using this. Go back to designer. After that configure and submit. We're going to create a new experiment. The name is MS Learn Diabetes Training. Okay, so the job display name is diabetes training. Okay, so next we don't change this one. Then in the compute instance we select the compute instance, then select the Ryan ComI. Okay, the rest we don't change any, then we submit. Okay, then the job is submitted. Yeah, it will take a while, a few minutes to complete this pipeline. Yeah, just wait for a while. Okay, after waiting for a few minutes, then we check in the jobs. Okay, so refresh, and this is the job. Yeah, okay, then after that let's see that it's still running. Yeah, almost completed. Okay, just wait for a while until totally completed. Okay, done. Yeah, so you can see the data has been normalized. When you preview the transform dataset, you can see all the numeric column already been uh, converted into the min-max. So the min-max, the value between 0 and 1. Yeah, so most of the value are between the 0 and 1. Okay, so we close this. Okay, now the next step is to continue preparing the training the model by splitting the data and then add the algorithm. So go back to the designer. We look for the split the data. Okay, then after that we're going to add uh, the algorithm, which is the two-class logistic regression for the classification. So the name is two-class logistic regression, but this applied to the classification. Don't be confused with the name regression, but actually this is used for the classification. Okay, so the output of the normalized data is passed to the split data, and then in the split data we're going to configure to have 70% of the data for training, and then the 30% for the testing. Okay, and then we going to assign the seed number for reproducibility, so just to make sure that when we rerun we get the same data set, yeah, which was already been randomized with this seed number. Yeah, this one is a seed number for the pseudo randomizer. Okay, then save it, then close. Okay, after that we look for the train the model. Okay, so the untrained model passed to this, then training data set passed to the right side. After that we continue with score the model. First in the train model we going to predict, yeah, the name is diabetic column. Okay, yeah, this one is the column which the output is 0 or 1. Yeah, so just now I show you here in the split data. Yeah, so maybe we look at the original one, this one. Yeah, okay, preview the data. There is a one last column named diabetic. Yeah. Diabetic. Yeah, okay, diabetic, diabetic. Okay, diabetic. So uppercase. So we're going to predict that. Yeah. Okay, after that save, and the rest is actually to save time you can directly add the evaluate the model. Yeah. Okay, then this testing you drag here. Okay, after that I will add the evaluate the model. Then drag here. Okay, so let's save, and then after that configure and submit. So we use the existing experiment, then just submit. Okay, so this will be taking a while. Let's go back to the job. Okay, so as you can see, here you go, the new job is running. Yeah, previous one was taking about 3 minutes, so this will be taking longer time because we trained the model. So we're going to see this again in about 5 minutes from now. Okay, so after 3 minutes 6 seconds, then the job completed, and we can check from here. Okay, yeah, so the training the model completed, and we can evaluate the model. Yeah, so we enlarge this, then look for the matrix. So we can see the accuracy is about 0.78, and then 0.85 is a area under the curve or the AUC, and also F1 precision, recall, and so on. So last time I already have covered the meaning of this matrix here. Okay, and then for the confusion matrix, you can view as table. Okay, now you see here, yeah, predicted label 1, so this is the true positive here. So predicted as diabetes, and the actual is yes. And then predicted as diabetes, but this one is no. Yeah, so this is false positive. Predicted 0, actual is 1. So this is false negative 397, and predicted as 0 and the actual is 0, that means a true negative. Okay, so not bad. Yeah, normally for the ROC curve, yeah, so we draw the diagonal line, and then after that we have the 0.5. Yeah, but this one is the AUC is 0.8 something, so meaning much better compared to the just naive guess, random guess. Yeah, 0.5. Okay, so now we're going to compare the okay, before that maybe I can show you that how actually this prediction is done. Yeah, okay, in the score model. Yeah, so we're going to preview the data score data set. Yeah, okay, so you scroll to the right, and then during the training, then the machine learning will provide the score. You see here, score probability, yeah, 0.6, and the default cutoff is 0.5. So meaning if the score is less than 0.5, then it will be considered as 0. Yeah, you see here, if less than 0.5. Yeah, but if it is greater than 0.5, like 0.6, then 1. So you compare this. Yeah, this one is a true negative. Yeah, this is true positive. Yeah, then after that this one is predicted 1, but actually is a 0. So this is false positive. Okay, and then true positive, yeah, true negative, false positive, and this is a false negative. Yeah? So it is the patient is diabetes, but the score is only 0.42. That means the prediction is negative. Yeah? So this is a false negative, and so on. Yeah. Then after that, it will be put into the graphics, yeah, or chart. Yeah. Okay. Then you're going to add the additional algorithm, which is the second algorithm is a two-class boosted decision tree. Okay, so I go back to the designer. Okay, so I'm going to a little bit rearrange this to make it a little bit smaller, like this. Yeah. Then train the model is here, and the score model is here, and also evaluate the model. Okay, so I need more space. I put here. Okay, so this time I'm going to oh, sorry, split the data is there, so I put the below here, nicer, like this. Yep. Okay, so we put one row below the split the data. Okay, so two class boosted decision tree. So I'm going to select for the two class boosted decision tree. Okay, here you go. I track here, and then train the model. Okay, then score the model. Okay, for the evaluate model, you can compare one into one like this, yeah, or you can also put as a separate. So here I'm going to use a single evaluate model. So here I pass to the untrained model. Then for the training data set, I put here. And then for the output of the train, I pass to the score the model. But this time I will have to edit the column, diabetic, the column name. Yeah. Then after that, save it. Yeah. Close. After that, you pass this into here. Then the testing dataset you pass to the right side of this. Okay, and the output we put to the right side. Okay, so the score dataset. So this is a boosted decision tree. So we can compare, yeah, this one. So I save it. Then after that, submit again. So use existing one, then just submit. Okay, this will take a while. Yeah, so I go back to the jobs. Yes, okay, running. Yeah, so this will take about 3 to 5 minutes. Just wait for a while. While waiting, we look at the screenshot that we have to collect. Yep, so here we have done the 1 2 3 screenshot. Okay, provide screenshot of created classification pipeline designer. Okay, this one we can wait until completed. Yeah, then successful execution of the pipeline and evaluation result. Okay, this one is in the jobs. Yeah, then comparison different classification model pipeline successful execution. Okay, so this 3 screenshot have to wait. Yeah, so refresh. Okay, completed. Yeah, so let's have a look. Okay, so we make it a bit smaller, and then we take this height. Yeah, okay, so this one. So this we can take the screenshot completed already. Yeah? Okay, here you go. Then after that, put here. Okay, completed successful execution. This one. Okay, then after that, designer. Yeah, in the designer, we go back to designer first. Okay, after that, yep. So we hide this one. Okay, then we minimize a bit the size. Okay, here you go. Good. Yeah. So this is in the designer. Okay. Then we put in the screenshot designer. Okay, you go. Okay, the last part is to provide screenshot comparisons different classification model pipeline successful execution. Okay, let's see in the jobs. Now here you go. This is the evaluate the model. So we double click, expand. Then we can see the matrix. Okay, this one. Yeah. So left is the logistic two class logistic regression, and then on the right is the two class boosted decision tree on the right. Yeah. So 0.7, and then after that the accuracy. Yeah, accuracy. This one. Right is 0. Okay. So this is very good. Yeah, much better than this. The AUC also the right side is higher. F1 also higher. Overall, the boosted decision tree is much better compared to on the left. Yeah. Okay, then this one is confusion matrix. View as table. Okay, you see the true positive is 910 and true negative is 1900, and a false positive and false negative is very low. Yeah, 60 60 yeah, 60 60 plus only. While if you compare with this, okay, so the false positive and false negative is much higher, 240 300, so almost 4 to 5 times. Yeah, so the boost two class booster decision tree is much better in the, and the ROC curve also almost 1, yeah, 0.9 something, which one is which indicate that this one is much better, 0.99. Yeah. Okay, so now you can create this screenshot, evaluate the model. Yeah. Okay, so put here comparison different classification model pipeline. Okay, yeah. So if you want, you can also scroll down, then after that screenshot this, the other chart. Yeah, like this. Okay, or you can yeah, I think this one is okay. Yep. So one more screenshot. Okay, so let's have a look on the instructions. When the whole setup is built, you can configure and submit the job. Okay, done already. Yep, so this is the assignment 2. We have in summary, we have already completed the task to create the Azure machine learning classification model to predict whether the patient has diabetes or not. Yeah, and then we compare the two algorithm, two class logistic regression and the two class boosted decision tree, and the result is the two class boosted decision tree is much better, yeah, compared to the two class logistic regression. Okay, let me close. Don't forget to delete this the workspace. Yeah.